Right. Okay, now I'm going to discuss some few questions in the friction tube, right? So let's uh, move to the fifth question. A force of 60 Newton is applied to a wooden block of mass 5 kilogram placed on a smooth surface as shown in the figure. Calculate the acceleration of the block. Right. Now here, initially, this block is kept on a smooth surface, not in a rough surface, right? That means there's no any frictional force apply on this object. Then now this force is 60 Newton with the inclination with the horizontal is let's assume that's 30. Right. The angle of this object is 30, right? So now, so let's mark the forces which is exerted on this object. So first of all, we have to mark the weight of this object is 50, and these two surfaces are contact. So then there's a friction, there's a normal reaction exerted on this object, which is exerted from the surface, and according to the Newton's third law, an opposite force exert on this force on this surface, right? Then now we have to calculate the acceleration. Now by exerting this kind of force in this direction, the object tends to accelerate in a horizontally right side, isn't it? So then now we have what to do is we have to resolve this 60 Newton force vertically as well as the horizontally. So if I resolve this force horizontally, it should be 60 cos 30. If it is resolved in a vertically direction, it should be 60 sine 30. And these are the forces which is exerted on this object in a vertical direction, right? So as a result today, now there's only one force which is exerted in a horizontal direction. So let's apply F equal ma for this object, right? Then F equal to 60 cos 30 equal ma. Cos 30 means root 3 over 2 equal 5a. And if it is, a can be considered as 6 root 3 ms minus 2. Right? So this is the acceleration. So if I further simplify, this is 30. Sorry, it should be right. It should be 6. Right. So in the second question, if the coefficient of the dynamic friction between the table and the wooden block is 0.3. Alright, so in this second instance, we have to consider this surface as a rough surface. So then there should be a friction force exerting on this object, right? So if I resolve this 60 Newton horizontally, it should be 60 cos 30, and vertically downwards we have 60 sine 30, right? So then this object tends to move down right side horizontally. Then the friction force should be exerted opposite to opposite direction, right? And if we further mark the forces, the weight should be 50, and the normal reaction which is exerted from this surface, let's consider it as R, right? Now, in the first question, in the A part, you are asking find the normal reaction. Right. So then now this object move in a horizontally towards right direction, right? So if we consider the perpendicular direction, that means vertical direction, so we can able to consider that this object is at rest in a vertical direction, right? Hence, we can able to obtain an equation by considering vertical forces, the equilibrium state of this object, then 60 sine 30 and 50 is exerted downward direction, so it should be equal to R. So 60 sine 30 minutes half plus 50 equal to R. Then it should be 80 Newton. So then R should be equal to 80, isn't it? Then in the B, find the friction force, right? Now they mention that this object is now in this question they are mentioning that coefficient of dynamic friction. Okay, then you should have to identify or you should have to understand that this object is moving, because that's why they gave it as a dynamic friction force, because dynamic friction force is applied in the in an object which is moving in the direction of right. So then obviously we have to use F equal mu r here. Mu mean 3.3, that's mean 3 over 10. R should be equal to 80. So then the answer should be the 24 Newton. In the C part, hence the find the acceleration of the object, right? So now let's apply F equal ma horizontally. Then we have two forces horizontally. The first one is 60 cos 30 minus it should be 24 equal to m a. Right. If I further simplify this one, then we have root 3 over 2 5a. Then 30 root 3 minus 24 5a. Okay, if we consider the value of root 3 as 1.7, then if I make a simplification, then this should be 51 minus 24 equals 5a. That's mean 27 equal 5a, then a should be equal to 5.4 ms minus 2, right? So this is the acceleration, right? So now you have to be familiar with this kind of simplification, right? Right. So in the 8th question, they have given that the weight of the A block is 4 Newton and the weight of the B block is 8 Newton. And there's a friction force between each surfaces. That means there's a friction force between these two surfaces, as well as there's a friction force exerted between these two surfaces, right? Then now we have asked find the value of F required to slightly move block B at each time. So that's mean let's consider this one as the force. Let's name it as P, right? Okay, now in this question they are mentioned that this object slightly move, right? So that means slightly move mean the still the object is at rest, right? But now by exerting this force, this object tends to move or nearly to move. So that's mean we can able to consider that I mentioned that now if the object is slightly moved or is close to the more near to move, still we can able to consider the object is at equilibrium state. Right? So that's the importance of this word. Right? So first of all, let's mark the forces. Now let's start with weight. This is 4 Newton. and this is the 8 Newton. Right. Then there's a free normal reaction between these two surfaces. Isn't it? Let's call it as R1, and there should be another normal reaction between these two surfaces. That is, let's call it as R2, and according to Newton's third law, there's a opposite. There's a reaction exerting on the surface, right? So now by exerting this force, this B object tends to move right direction. Hence, this surface exert a friction force towards opposite direction. So let's call it as F1. At the same time, so we can able to mark the F1 in these surfaces toward this direction, even though the surface doesn't move, right? Now, normally we consider this surface is at rest, it's a stationary object, right? So when B tends to move down in towards the right direction, this A force exert a resistance force towards the opposite direction. So that is known as the friction. Now we can able to consider this one as F2, and according to Newton's third law, F2 exert on the A object toward this direction. That means towards the opposite direction for this F2, right? So now we have completely marked the forces, right? Then now if the B object, slightly to move, if the object is slightly to move, that means P can be equalized to F1 and F2, right? Then now in order to obtain the P value, we have to first of all we have to obtain the value for F1 and the F2. Now Pute, you can able to consider the free body diagrams, right? So now I'm not going to draw this object again, but try to differentiate from A object from the B object, right? So if you consider the A object, you can able to figure it out that R1 should be equal to 4 Newton, isn't it? Right. So then now we can able to consider the F equal mu R, and all right. So then now you might have a questions that which equation that we use here, is it if equal mu R the static equation, static position, or the for the moving object? So they normally, unless they mention the coefficient as a static, the coefficient of static friction or coefficient of dynamic friction, we can consider as mu as 1/4, right? You don't need to worry about mu S or mu K, right? So then just apply it equally mu R, right? That's it. No need to worry about the dynamic or static state. But even though you can able to figure it out that now they mention this object is nearly to move. That means still we can able to consider still the object is at rest. So then obviously this given coefficient should be equal to static coefficient of static friction, right? Okay, now let's find out if F1, now sorry, F2. Now, you know that to obtain, when obtaining F2, you have to consider this R1, right? So, mu equal to 1/4, R1 should be equal to 4, then it should be 1 Newton. Right, now let's consider the B object. If you consider the B object, we can able to consider that by considering vertical forces, R1 and 8 Newtons exert downwards and R2 exert in upward direction. So then we can able derive an equation R2 equal to R1 plus 8. Right, then now we already have obtained the value for R1. That means 4 plus 8, then it should be 12 Newton. Right. So when you obtain the value for F1, you have to consider this equation here. We have to substitute 1/4 instead of mu, and R should be, now we are obtaining the value for F1. Now, if you are obtaining F1, you have to consider the R2 force and not the R1. Right? Now, we have already derived an value for R2. Then it should be 3 Newton. Right. Hence, the final answer should be P equal to, if 1 is 1 Newton and if 2 is 3 Newton, then the answer should be the Newton, 4 Newton. Right? So this is the expected value for P to slightly move this object. So let's assume that if we assert a greater force than the force, then greater force than the 4 Newton, then obviously this B object should be moved towards right direction, right? Okay. Then let's move to the second question, second diagram. Right. After drawing the force, after drawing the diagram, let's mark the forces which is exerted on this object, right? So now you can able to figure now Uday, now this should be considered as a string. This is a string, isn't right? So then what we do is now we are exerting a force toward this direction. So first of all, let's mark the forces. Let's initiate with the weight. Now we know that the weight of this B object is 8 Newton and the weight of this object is 4 Newton, right? And let's mark the normal reaction. So we have R1 in upward direction and it should be set on the B object too. And due to this contact, there's a normal reaction resulting from the surface on the B object. According to the Newton's third law, the same force should be exerted on the surface in opposite direction. Right. Now this, by using this force, this B object tends to move towards right direction. So then this surface exert an opposite force towards the left side. That is considered as the friction. Let's call it as F2. So according to Newton's third law, there's on F2 also exert on the surface, even though you can able to neglect it. Right. Now, when this B object tends to move right direction, due to apply this P force, A is not allowed to move right direction easily, right? This A object doesn't allow to move for this B object, right? So that's why A object exert a opposite and force in towards the opposite direction, and it is called as the friction force, right? So friction force should be exerted on the B into the left side, and according to the Newton's third law, the same force should be exerted towards right direction, right? So now, because this is a string, so that means there should be a tension on this B object, right? So then, now we have drawn the forces relevant to this diagram, right? So now we can also consider that this object is nearly to move or close to move. Hence, we can able to consider that this object or this both object is at equilibrium state, right? Then let's go for the calculation. As we did in the earlier question, we can able to isolate the A and B object. That is, we can able to consider we have already marked the forces, and we can able to obtain some relationship between the forces by considering this equilibrium state of this object A and B separately. Let's consider the A object Okay, if you consider the A object, now A is at rest, right? Then obviously, by considering our vertical forces, R1 equal to 4, right? On the other hand, if we consider the horizontal forces which is exerted on the A object, we can able to consider that F1 should be equal to T, right? And we also can able to obtain the value for F1 by considering F equal mu R, then mu mean 1 over 4. So here R mean 4. So that means F1 should be 1 Newton. So if you asking about the tension of the string, it should be also equal to 1 Newton, right? So then let's consider the force object B. Then we can able derive an expression by considering vertically forces, that is R1 plus 8 Newton should be equal to R2. Even though we have obtained that R1 is equal to 4, then R2 equal to 12 Newton. Sorry, 12 Newton. Right. Then, if you consider the forces which is exerting on the horizontal direction, we can able to derive as F1 plus F2 equal to P. Right. So now we have to obtain a value for P now. Then F2 can be obtained by using the same equation. 1 over 4. So here R should be substitute as R2, right? So R2 value is 12. That's mean 3 Newton. So obviously overall P should be equal to 1 F1 plus F2 mean 3. So that's the answer for the second diagram. Right. Let's come to the C diagram. Here we have a different setup. Right. Okay. Now these objects are connected using a string, right? And it is move over a smooth pulley. Right. So what happened when we exert a force toward this direction? This object tends to move right direction. As a result, this this A object tends to move towards the left side, right? So let's mark the forces. We already know that the value for this object is 4 Newton. And the value of this weight of this object is 8 Newton, right? And there are normal reaction exerted between these surfaces. First one is R1. R1 also exerted on this P object. And there's a normal reaction between these two surfaces, isn't it? That is R2. And it should be also exerted on the surface, right? So now, on the other hand, this B object tends to move right direction. Hence, the surface exerts a friction force on the B object. Let's call it as R2. And the same force should be exerted on the surface too, right? But we can able to neglect this force. And okay, when this object tends to move right direction, A object also exert a resistive force towards the left side, right? So this should be marked as 1, and on the other hand, F1 also should be marked in the A object too, right? So we can able to consider this marking this force by considering the B object. Now, when you asserting a force on the B object towards the right side, this A object should move towards the left side. Hence, this P object also asserting a opposite direction on the A object, right? So F1 can be marked by considering either A object or B object, right? Even though you obtain the same answer, right? And here, okay, there's a tension on the string. So we also have to consider this tension of the string. Let's call it as T, and T should be also asserted on this string also. Right. So then here, if you consider the A object, okay, we can able to obtain an expression by considering vertical forces as R1 equal to 4 Newton. Then, by considering the horizontal forces, we can able to derive P as F1. Right? So until we don't obtain a value for F1, so that's why let's apply this F equal mu R. Then F1 should be equal to 1 over 4, R should be equal to 4, then it should be 1 Newton. Right. So let's consider the B object. If you consider the B object, if you isolate the B object, you can able to derive an expression in a vertical direction as R1 plus 8 equal to R2. Then obviously we can able to substitute the R1 as 4 plus 8, it should be R2. Then R2 equal to 12 Newton, right? Then if we consider the forces acting on a horizontal direction, we can able to consider that P equal F1 plus F2 plus T, right? Then we didn't obtain a value for F2, isn't it? So F2 can be obtained, F2 equal mu. Then instead of R, we have to consider R2, right? Then 1 over 4, R2 means 12. Then it should be 3 Newton, right? So let's substitute the F1 should be 1, F2 should be 3, and on the other hand, T is also equal to F1, so we have to consider it as 1 Newton. So the overall answer should be the 5 Newton.